Okay, we're going to start solving some quadratic equations now. And in order to do this, we need to firstly clarify a couple of things. All right, firstly, right, if we're just let's look at solving. You've solved some different types of equations in your life. Yeah, let's look at sort of this sort of thing, which is a linear equation. You go through and the idea of solving equations is to find out what the value of the unknown is. So in this case, we've got a little technique: 3 times what plus 1 equals 5. Well, that 3x must be equal to 4 in this case. So x was going to be equal to 4 over 3, and that was it. Done. One solution all over. That's the value of x that solves this equation. Okay, but that's a linear equation. We're talking about quadratic equations, which are, hopefully you have picked up, that quadratic equations are squared equations. So, right, what happens when we look to solve x squared equals 16, for instance? So what's happening with that? So, all right, well, what squares to 16? So what we do here is go, okay, well, x is equal to what squares to 16? Well, there's a square root of 16. Yeah, well, that's 4, isn't it? So 4 squares to 16, but is a really important mathematical rule that we go back to a lot, is that you square anything, you end up with a positive. So is it true that there's another solution here, that actually you can also square minus 4 to get 16? So in actual fact, there's a plus or minus solution here to look at. So the solution to x squared equals 16 is not just 4. Yeah, 4 is a solution, but it's also minus 4. So we can write that as plus minus 4, like that, 4 or minus 4. If you square either of those, you end up with 16. So there's this thing about quadratic equations. There's this feature of quadratic equations that there are up to 2 solutions. There don't have to be 2 solutions. Now, for instance, x squared equals 0. There's only one solution to that. That's x equals 0. Nothing else squares to 0. There's one solution. So we can have one solution. We can have 2 solutions, as we do here. We can actually have 0 solutions. Can you think of an example where there is no solution to a quadratic? We've just said that you square anything, you get a positive number. So what's the solution to x squared equals minus 1? What squares to minus 1? There is no solution to that. So to that one we say no solution. So we can have 0 solutions, 1 solution, but typically we'll get 2 solutions, and we're expecting 2 solutions with a quadratic. So let's just make that note. All right, with quadratic equations, okay, so we can expect up to 2 solutions with a quadratic, and like with a cubic, we can expect up to 3 solutions. So whatever the power is of the equation, that's how many solutions to the problem we can expect, to the equation. Okay, I'm going to bring in another really important principle here. It's one you'll know and you'll be aware of, but we're going to bring it to the forefront so that we can use it. I'm going to go for a different color here. That's how important this is. When a times b is equal to 0, or when a times b, or if a times, maybe if's a better word there, if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. Okay, so let's just clarify this. If we know that the product of 2 things, 2 factors, equals 0, we know that that's the case, then in order to solve that problem, and this is going to get back to factorizing and become really clear in a moment, then, well, if a is 0, then it doesn't matter what b is. 0 times anything is 0. So either a or b will be 0 if a times b equals 0. So hold that in your thoughts as we go on to look at some examples of some quadratic equations. Right, so we'll have a look at some examples here, and we'll start off with solve. Right, we'll just do a quadratic binomial to start with. X squared minus 2x equals 0. So with any sort of quadratic equation, we're looking to factorize first. That's why we went through all those factorization skills. That's why I emphasize it so much. because solving equations is based on factorizing. So first, factorize. Okay, I should have said first actually, get 0 on the right hand side. Secondly, factorize. But right, we'll just go with that. So factorize, we're going to factorize x squared minus 2x. So we take out the common factor and we got x there, and inside we get x minus 2 equals 0. So we've just factorized the left hand side. That's a really important part of this. Now we're going to use this principle here that a times b equals, if a times b is equal to 0, if a times b, my b is x minus 2 in this case, is equal to 0, then my solution will either be this is equal to 0, my a, or in this case my x equals 0, therefore x equals 0, or x minus 2 is equal to 0. Think about that. If x is 0, then I've got 0 times, who cares? If x was 0, there would be minus 2 here. I get 0. So x equals 0 solves this equation. 0 times, you can see, minus 2 equals 0, but we don't even need to evaluate that. Okay, so sorry, just an intrusion in the room there. I had to pause the recording. So x equals 0 solves this equation. Right, we've got that. Or if x minus 2 equals 0, that's going to solve the equation. So that's x equals 2. So my two solutions here are x equals 0, because 0 times whatever will equal 0, or x equals 2, because when x is 2, what happens to this bracketed expression? 2 minus 2, this becomes 0. So in effect, when x is 2, I get 2 times 0. That's also 0. There's my two solutions to this quadratic equation, and we're done. Okay, let's have a look at another example. Okay, we're having a look at now a quadratic trinomial. So we're going to go ahead and factorize first. That's our job. So factorize this expression here. I've got 0 on the right. Beautiful. Factorize this trinomial. How do I do that? I'm looking for two numbers that, multiply to this here, 6, and add to minus 5. What are those two numbers that multiply to 6 and add to minus 5? Be great if you could come up with those. Pause here and come up with them on your own. You might have thought of them already, but I've got myself minus 3 and minus 2 are my two numbers that do that trick for me. So I'm now going to come in here and factorize this to x minus 3, x minus 2 equal to 0. Now I'm going to use the fact that if I've got a times b equal to 0, then I'll solve it by making my a equal to 0 or making my b equal to 0. So I get my two solutions from x minus 3 equal to 0 or x minus 2 equal to 0. So what I end up doing is solving these two equations now. X is equal to 3 or x is equal to 2. Right, let's just check that. When x is 3, I get 3 minus 3, I get 0 here. I get 1 there, but who cares? 0 times anything is 0. When x is 2, this part of my factor is equal to 0, so 0 times this has to be equal to 0. X equals 3, x equals 2. They're my two solutions to x squared minus 5x plus 6 equals 0. We get there by factorizing and using the principle that this, if I've got a times b equal to 0, then if either a or b is 0, my product is 0. Next example. Okay, here's my next example. Solve another trinomial, x squared plus 2x plus 1 equals 0. So I'm looking for two numbers that multiply to 1 and add to 2. Well, multiply to 1, it's got to be 1 and 1, hasn't it? 1 and 1. They multiply to 1, they add 2, so I've got x plus 1, or it's x plus 1, isn't it? X plus 1, or x plus 1 all squared equal to 0. So, therefore, x plus 1 must equal 0, or x plus 1 must equal, this is the same equation, so I don't need to write that out twice. X equals minus 1, I get one solution. Here's an example of a quadratic equation with one solution. When x is minus 1 plus 1, 0. That gets me 0. But obviously when I put minus 1 back up here, minus 1 squared is 1, minus 2 is minus 1 plus 1 is 0. That solves my quadratic. Only one solution. One more example. Okay, in this example, I've got it set up a little differently. It's obviously a quadratic, but I don't have 0 on one side, so when I said first factorize, not in this case, we're firstly going to get everything on one side of the equation. So in this case, actually, I'm going to firstly expand, so I get 4x plus 60 there, and then I'm going to get everything across to the left-hand side. Now I'm in business. So the note here is to get 0 on right-hand side of equation. That's got to be done first. Now, once you've done that, now we can factorize. All right, let's have a go at this. We're getting good at this. Multiplies to minus 60, adds to minus 4. Okay, what multiplies to 60? 61, 30, and 2. I'll put the numbers over here. 2 and 30, 3 and 20. We're not even close. 4 and 15. I needed to get to 4, don't I? 5 and 12. That's not there either. 6 and 10. What about 6 and 10? That's got a difference of 4. I want to multiply to minus 60. I reckon I'm on at this, and adds to minus 4. So how about minus 10 and 6? Does that do the job? Minus 10 and 6. Does that get us minus 4? It does. So therefore, x minus 10 and x plus 6 as my factors equal to 0. And therefore, x equals... if you want to, you can jump straight to the solution at this stage, if you can see it. But this step here, x equals 10 equals 0, or x plus 6 equals 0, is going to get me my solutions of x equals 10 or x equals minus 6. You might have noticed that the solution is the opposite to the term in the bracket. So x minus 10 gives us a solution of x equals 10. X plus 6 gives us a solution of x equals minus 6. So the opposite sign to what's in there. That solves my quadratic equation there. Firstly, I had to get 0 on the right-hand side. Okay, that'll do in terms of explanation and examples and things. We can get some more practice in class on exercise 5F. So I'll see you then.